Alright guys, welcome back. In today's video, we're going to be solving another question from chapter 4 of Johnston textbook, and we have this 6-meter telephone pole weighing 1600 Newton that is used to support the ends of two wires. We know the wires form the angle shown with the horizontal, so the left one has the angle of 10 degrees and the right one has the angle of 20 degrees, and the tension in the wires are so the left one, which is T1, is 600 Newton, and the T2 is, so there's T1 and T2 missing in here, 375 Newton. So we need to determine, I don't know what, so this 12 is a typo, ignore that. So we need to determine the reaction at the fixed end A. So as always, we're going to start with the free body diagram. So we have this pole, and we have to figure out all the reactions that we have. So at point A, we have a fixed support, meaning we have X and Y component. Let's call this AX, this AY. And since it's a fixed support, the rotation or the moment about point A is also limited, which means we have to consider a moment. Let's call it MA, great. And we have the two tensions, so let's consider this our horizontal line. The T1 is making 10 degrees with horizontal, and T2 is making 20 degrees with horizontal. Let's see if we are missing something in here. Yeah, we missed the weight of the pole, which is, let's show it in red. We can see it better. We have the weight of the pole. Let's call this one 600 Newton, which is applying to the centroid of this bar. And that's pretty much everything for the free body diagram, and we're good to go with our equilibrium equations. So we are in equilibrium, which means the sum of all forces in x and y direction is equal to 0, and we have the same thing for the moment. And looking at this, we'll see we only have one unknown in x direction, one in y direction, which means it really doesn't matter go with fx or fy or even the moment. We have to do all of them three, so the order really doesn't matter. So let's go with the fx, and this will be our positive direction. What we have in fx is ax. We have the x component of t1, which is negative, so it will be this force. So it will be minus t1 cosine of 10 degrees, and we have the x component of t2, which is this force, so it is positive t2 times cosine of 20 degrees. And great, we have everything in x direction. We know t1 is 600, we know t2 is 375, and we are left off with only one unknown, which is ax. And there we go, we have 238.5 Newton. For ax, no negative sign, which shows our assumption at the beginning for ax, which was the positive direction, is correct. So one is out, we have two more to go. Let's go with the fy. This is our positive. Let's see what we have in fy and y direction. We have ay. We have the y component of t1 and t2, which are both negative. So we have minus t1 times sine of 10 degrees. Same for t2, sine of 20 degrees. And we have the weight of the pole 2, which is 1600 Newton, equals 0. And great, we have only one unknown in here. We know t1 and t2. So from here we can find the second unknown, or ay, which is 1832.45 Newton. No negative sign. Our assumption was correct, and that's the direction for ay. So now we have x and ay. We can find the magnitude of the force, which will be the square root of ax squared plus ay squared. So we have square root of 238.5 squared plus 1832.45 squared, and this would give us 1848 Newton. And it's not over, we have to find the direction of the A2, so we found AY and AX in these directions. and the resultant of these two is gonna give us A. And let's find this angle theta. So we know theta will be the tangent inverse of AY over AX, and we can just put the absolute value of AX and AY, but in any case both of them are positive, so we don't need to be worried about at all. But even if we have one of them negative, we put the absolute value because this direction already counts for the sign. So all we need to consider is just these right triangle here, and we put the sides. The side of triangle cannot be negative, so whatever amount we have for AY and AX, we just put it in here. Or as I mentioned, it's not the case in here, but we solved question in the previous videos that we had negative sign, so we don't need to get confused. We just go straight with the absolute value of each. And we have tangent inverse of AY, which was 1832.45 divided by 238.5, and that's gonna give us 82.6. And if we want to write down the final answer for A, we will have 1848, don't forget the unit, and the angle that we have in here is 82.6. That would be the final answer for A, but we still have one more unknown, and since it's a fixed support, we still have to figure out the MA, and we can go with the moment about point A. Counterclockwise positive as always, and we're gonna do that to the shortcut that we have that we've been using for a while, and there's a video for that. I'm gonna put the link in the description, so feel free to check that one out. And let's see what we have for the moment about point A. So first of all, we have the moment of MA, which is what we are looking for, and it's positive since our assumption at the beginning was counterclockwise, so positive. And if you look at the other two, so obviously we don't have any moment for X and AY since the distance vector is 0, but let's just go with the other ones. So 1600 also doesn't make any moment. And looking at this, the X component, the Y component of T1 and T2 also won't make. So these two also don't make any moment. So all we have to do is to find a moment of X component of T1 and X component of T2. And we already figured out the X component is T1 cosine of 10 and T2 cosine of 20 degrees. And T1 is gonna make counterclockwise moment positive, and T2 is gonna moment clockwise. So a positive sign for T1 and negative sign for T2. And that's pretty much it. And the distance that we have is pretty much the length of the pole, which is 6 meters. So from the thing we know that the length of the AB is 6 meters. So let's do that. So we have, as I mentioned, T1 positive, cosine of 10 degrees, the length is 6. T2 negative, cosine of 20 degrees, distance 6, and that would be equal to 0. And from here we can find the last unknown that we're looking for, which is MA, and that would be negative 1431.00 Newton meter. And this negative sign shows that the moment is clockwise. And that's it. We found the unknowns that we were looking for, and that would be the final answer for this question. Please make sure to subscribe to the channel and share this content with your friend that needs some help, or they might find this helpful. It's gonna help me to grow the channel faster. And you guys take care. I'll see you in the next one.